Hello and welcome to the channel. In this video, we will start with the quadratic formula, its generalized form, then jump into a new way of finding it using the fact that a quadratic function is symmetrical. We will then talk about how it works and even use the idea for other functions. Let's start with a review of the usual way to get the formula by completing the square. We start with the function, then set it to 0. Then the key move is to add b squared over 4a squared, then collect the terms and taking the square root. If we instead use an arbitrary value y instead of 0, we will get the following formula, which will be explained later on. What's great about completing the square is that it's not only a way to find the quadratic formula, it also makes it clear what kind of transformation done to the quadratic, such as shifting left, right, up, down, or both. Now, let's check the other method using symmetry. If we pay attention to the graph of the quadratic, we notice that for any value of the function, except for the value at the vertex, there is two corresponding inputs. For our example, both 1 and 3 gives us the output value 2. Not only that, if we measure the distance starting from the coordinate of the vertex, which is 0 to 3, it will be the same as the distance starting from the vertex 2 to 1. We can express this result in terms of absolute values, then we can get the distance to the vertex as the average of the two inputs, x1 plus x2 over 2. This will be our key relation to figure out the generalized quadratic formula. First, let's find the vertex xo in terms of the coefficients. If we substitute x1 and x2 into the function, they will give us the same output. Now we subtract and get the following. We factor the x1 squared minus x2 squared and move a term. x1 plus x2 is equal to 2xo from the relation we found earlier. After rearranging, we get the well-known formula for the vertex. We now move over to get the entire formula. We add the two functions. For x1 plus x2 we substitute minus b over a. Now we need to deal with x1 squared plus x2 squared. We use the formula of the average x1 plus x2 over 2. We square both sides and rearrange. We substitute 2xo minus x1 instead of x2 and expand. We take 2x squared and put it to the side. Now we can take the rest of the terms and group them. After simplifying and moving the terms, we now get the well-known formula we saw at the start of the video. To answer the big question now, how does it work? In fact, how did we get something similar to the inverse to a function like the quadratic? If you are familiar with the horizontal test, this function clearly fails it, meaning we have an output that's tied to more than one input. The question is answered with symmetry. Remember that on the Cartesian plane, to get the value of a point, we need to measure from the origin. So our goal is to reach 1 and 3 by adding the pieces. The vertex formula measures the origin to the vertex, and the square root term measures the distance to a point starting from the vertex. To reach the value 3, we add the distance from the origin to the vertex plus the root term. To reach the value 1, we start from the vertex and subtract the root value. So all we have to do is to add or subtract these two pieces to get to the input. However, the formula doesn't distinguish between these two inputs. So it's kinda like the inverse function, but not totally, since we can't distinguish between which input was used. And the final question is, can we use this idea on other functions that have this type of symmetry? Any function that has this type of symmetry is called an even function. These are functions that are symmetrical across the y-axis. With our idea in hand, let's try and get a formula for the cosine function. In fact, this is how equations that have a cosine term in it is solved. So our plan is to apply the idea to the cosine function and get all the inputs that correspond to the same output. To see the effect clearly, we start with the cosine and shift it to the right by 1. Similar to the quadratic formula, we use symmetry and add or subtract two pieces to get to the inputs. The vertex could easily be found from the function by knowing at what input the cosine is equal to 1. But now, how do we get the distance to a point starting from the vertex? The answer is the cosine inverse. The cosine inverse gives us the distance measured from the vertex to a point, however it's restricted between 0 and pi. And so, we add or subtract these two pieces and get our formula. So now we found how to do it for one vertex, but the cosine function has multiple vertices. To get to a given vertex, we add or subtract 2k pi to the formula where k is an integer. And that's it. The same idea that we used for the quadratic is also used for the cosine. If you enjoyed the video, please consider subscribing, and see you in the next one.